Assalamu alaikum dear students. Today we will discuss about the different steps that are used for the extraction of metals, and this whole process is called as metallurgy. So as you know that an ore contains a metal in the form of its compounds with other elements. That is, metals are electropositive in nature, they are reactive, they are present in the earth's crust in the form of ore. So what happens when the ore is taken out from the ground by the process of mining? After that, it is converted into pure metal, and to obtain that pure metal, we have to study in detail the extraction of metals, and it contains three major steps. First one is concentration or enrichment of ore, second one is conversion of concentrated ore into metal, and third one is refining or purification of impure metal. So when ore is taken out from the ground after mining, the first step that is applied for it, that is the concentration of ore. What is concentration? As you know that concentration means the amount. In that very ore, it contains ore as well as other impurities. It is not 100% pure. This ore is not 100% pure. It does not contain only metal or compound. It also contains some impurities. So ore is an impure compound. The unwanted impurities like sand, rocky material, earthy particles, limestone, mica, etc. present in an ore is called as gangue or matrix. That is, the impurities that are present in the ore. You know that when the ore is obtained from the earth's crust, it contains a large amount of impurities in the form of insects, or in the form of dead rocks, in the form of dead leaves, in the form of dead microorganisms. That whole thing is called as gangue or matrix. So in this process, an ore is converted into a concentrated form. Concentrated form means this ore must contain large concentration of ore and small concentration of impurities. So in this method, we have to remove the impurities that are present in this ore, so that the concentration or the quantity or the amount of ore is increased. This process is also called as ore dressing or benefaction. So how are these impurities removed from the ore? Impurities are of various types. Some are visible and other are non-visible to our naked eye. Some are small and some are large. So there are various methods by which we can remove the impurities from the ore. So here I have discussed two methods. First one is picking, and second one is magnetic separation. So which type of impurity is removed by hand picking? If the impurities are large in size and differ from ore in size and shape. So if the impurities are visible, and only those impurities are visible that are large in size, and the impurities we can differ from them from the ore in its size or shape. So those types of impurities are easy to remove by this method, by hand picking. Second one is magnetic separation. So which type of impurity can be removed by magnetic separation? It is used when either ore or impurities are magnetic in nature. If ore is magnetic in nature, it means when we use a magnet, if ore is attracted by the magnet, the ore can be removed from it and the impurities are left. And if the impurities are magnetic in nature, the impurities are attracted by the magnet and removed from the ore. So it is the process in which magnetically susceptible material is separated from mixture using magnetic force. So there are various types of methods in which concentration of ore is increased. These were two methods. There are a large number of methods, that is froth flotation, gravity separation. These are some other methods and you have to study them in higher classes. So this was the first step by which we can remove the unwanted impurities that are present in the ore. Second step is conversion of concentrated ore into metal. So now we have got an ore, and you will remember it that it is not 100% pure yet, but it's the concentration of ore in this mixture is large. It is large. So in this second step we have to convert this concentrated ore into metal. And how can it be converted into metal? We have to keep some points in consideration. The extraction of a metal from its concentrated ore is essentially a process of its reduction. So when we extract metal from their ore, then we convert concentrated ore into its metal. The general method for this step is reduction of the metal, because metal is present in the form of ionic compounds. Metals are electropositive in nature, and these metals are present in the form of compounds, in the form of ionic compounds, and ionic compounds are formed when the metal reacts with non-metal. So here metal is electropositive, and you know that non-metals are electronegative. So in this very step we have to extract metal from ionic compound, and we can do it by the process of reduction. It depends on some points, that is, it depends on the reactivity of the metal to be extracted, because we know that ore is not present in one form. It's of different forms depending on the metal, depending on the on the type of impurities. So here this main point, you will remember it in this very step. It depends on the chemical reactivity of the metal to be extracted, because we know that on the basis of chemical reactivity metals are classified into three types. First is metals of high reactivity or highly reactive metals, second one is moderately reactive metals, and third one is less reactive metals. So in this table you will see the chemical reactivity and the type of metal. This is the decreasing order from top to bottom. The metals, the chemical reactivity of metal is decreased. So according to that very point, the highly reactive metal is potassium and the least reactive metal is platinum. So this first includes highly reactive metals. This second table includes column includes moderately reactive metal, and the last column includes least reactive metal. So potassium, sodium, calcium, magnesium and aluminum, these are highly reactive metals, highly electropositive metals, and they are present in the form of chlorides or oxides. Metal chlorides or metal oxides, these are present in two forms. Number second column includes zinc, iron, lead and copper. It also includes oxides. Third one is copper, mercury, gold, silver, platinum. So it includes mostly ores in the form of sulfides. So all the three types of metals need reduction process, but reduction is of different types. First one, as the first column includes the highly reactive metals, it contains here the metals are reduced by the process of electrolysis. Number second column includes moderately reactive metals. So here we have to use carbon as reducing agent. Number third is least reactive metals. So we can reduce the metals, the ore, heating sulfide in air, reduction by heating only, found in free state as metal. So we have to heat the sulfide, or through that very process we can convert the ore into its metal. So it includes three. So concentrated ore is converted into metal on the basis of its chemical reactivity. So we will study one by one how are metals converted into, how are ores converted into metal, how are metals extracted from their ores. We will start from less reactive metals. So it includes three different ways, but process is reduction. In general, all ores are reduced. All ores include reduction, but reduction is of different types on the basis of chemical reactivity of metal. At first we will study how are less reactive metals extracted. Extraction of less reactive metals. So the major metals, the examples of the metals that are least reactive are mercury and copper. Before discussing their extraction, there are two important processes you need to remember. First one is roasting and second one is calcination. So what is roasting? These are the two different as well as same processes. What is roasting? It is a process in which a sulfide ore is strongly heated in the presence of air to convert it into metal. If an ore is present in the form of sulfide, it has to be converted into metal oxide, because metal sulfide cannot be converted directly into its metal. So that is why at first the metal sulfide is converted into its metal oxide. So roasting is the process in which sulfide ore is strongly heated in presence of air. For example, MS, M is a metal and S is sulfur. It is a metal sulfide. It is strongly heated in presence of oxygen, and when it is heated it gets converted into metal oxide and sulfur dioxide. After that, this metal oxide is converted into metal by the process of reduction. So it is called as roasting. Calcination, when an ore is present in the form of carbonate, a process in which carbonate ore is heated strongly in the absence of air to convert it into metal oxide. So in roasting, metal sulfide is converted into metal oxide, and in calcination, metal carbonate is converted into metal oxide. And roasting involves presence of air or presence of oxygen, but it does not involve presence of oxygen. It involves absence of air. So MCO3, for instance, M is a metal, MCO3, it is metal carbonate. When it is calcinated, it gets converted into metal oxide and carbon dioxide. After that, this metal oxide is reduced. So this is the process of roasting and calcination. So now we will study the extraction of less reactive metal. If the less reactive metals are mercury and copper, these are extracted by the reduction of their oxides by the heat alone. As you know that mercury is present in the form of its sulfide ore, mercury sulfide, and that ore is called as cinnabar, HGS. It is ore of mercury, and in order to extract it, it involves two steps. It involves two steps. So HGS, it is not directly converted, or it is not directly reduced. Why is not it directly reduced? It is because it cannot, the metal sulfide cannot be, the bond between mercury and sulfur cannot be broken by the process of reduction. So at first the mercury sulfide is converted into mercury oxide, and after that the mercury oxide is reduced by using carbon as a reducing agent. So it involves two steps. First step is it is its first step, HGS. It is mercury sulfide. It is present in solid state. When it is reacted with oxygen, so which process is done on it? Roasting. Roasting. So when mercury sulfide is reacted with, or it is roasted in presence of oxygen, we will get mercury oxide plus sulfur dioxide. Mercury oxide will be in the presence of solid state, and sulfur dioxide, as you know, that it is present in gaseous state. So it includes first step, mercury sulfide is roasted in presence of oxygen and is converted into mercury oxide and sulfur dioxide. Now you have to balance this reaction. How can you balance it? So here there are two oxygen atoms. This is only one oxygen atom, so we will start from this, convert this one oxygen atom, odd oxygen atom, into even form. So the number of oxygen is 2 plus 2. Here mercury becomes 2, so here twice, 3 times, and 2 times. This is the first step in which mercury sulfide is roasted. After that, second step includes reduction of this mercury oxide. But this mercury oxide, it is heated to about 300 degrees Celsius. It is a type of decomposition reaction. So mercury oxide is heated, it is 2 times, it is heated in at a temperature of 300 degrees Celsius, and after that we will get mercury plus oxygen. So it is a type of reduction. What is reduction? Removal of oxygen. Here it was mercury oxide, and oxygen is removed from mercury. We get metal, we get mercury metal in free state, and oxygen is removed from it. It is twice mercury. So these are the two steps by which mercury is extracted from mercury sulfide. I will show you once again. So in first step we roasted mercury sulfide in presence of oxygen to form mercury oxide plus sulfur. Mercury oxide plus sulfur dioxide, twice, 3 times, twice, and twice. And in second step mercury oxide is reduced, HGO, reduction. Reduced matlab reduction. oxygen is removed, plus oxygen. So this is the mercury in free state. This is the extraction of mercury from its ore. This is the first example of least reactive metals. Now second example is extraction of copper. Copper is less reactive metal. It is very low in the reactivity series. Copper is present in the form of its sulfide ore. It is also present in the form of sulfide ore, that is Cu2S. Copper glance. This is the sulfide ore of copper. It also includes two steps, that is copper is extracted from copper sulfide by two steps. First one is roasting and number second is reduction. At first copper sulfide is converted into its copper oxide. It is because why are sulfide or carbonate ores first converted into their oxide? It is because it is difficult to reduce copper sulfide. It cannot be reduced, so that is why it is first converted into its oxide. It includes two steps. First step, copper sulfide. It is roasted in presence of oxygen and it is converted into copper oxide and sulfur dioxide. This is the first step in which copper sulfide is roasted in presence of oxygen. So it is converted into copper oxide and sulfur dioxide. You will balance this reaction. Second step, we have to reduce this copper oxide and convert it into free metal, that is free copper. Here it is the first step. When a good amount of copper sulfide is converted into copper oxide, then the supply of air for roasting is stopped. So here you will see that the whole copper sulfide is not converted into copper oxide. Some amount of copper sulfide is left. That left copper sulfide is reacted with copper oxide. For instance, this we get copper oxide from the first step, Cu2O. Here some amount of copper sulfide is left. For example, if we have 100 grams of copper sulfide, suppose 10 grams are left after this roasting. Those 10 grams are reacted with this copper oxide, because just like mercury sulfide gets roasted, gets converted into mercury oxide in the single step, but here some amount of copper sulfide is left, for instance 10 grams, though that amount is reacted with this copper oxide, and we will get copper metal in solid state and we will get sulfur dioxide. This is the reduction of copper oxide. These are the two steps by which copper sulfide is converted into copper. I will show you once again. So it includes two steps. In the first step, copper sulfide is roasted in presence of oxygen to form copper oxide and sulfur dioxide. After, in second step, we take this copper oxide, react with the remaining copper sulfide and we will get copper in the form of solid state plus sulfur dioxide. So here the copper sulfide, the ore, is converted into free copper, free metal, in two steps. First one is roasting and second one is reduction. So this is the extraction of less reactive metals. We will continue this topic in our next session.